Welcome! It's week 4 in the Newtonian Physics Laboratory in Phys 1 lab. We are working with springs this week. And of course, there are many varieties and designs of springs. There are compression springs, rotational springs, including extension springs, which is what we will use this week. So you stretch these guys and they pull back toward equilibrium. Now you want to be careful not to stretch them too far because you might exceed the elastic limit, and then they won't come back to their original shape, their natural length. But as long as you're staying within the linear region of that spring, the more force you apply, the longer the stretch. And the relationship between the stretch and the force that's applied, or balanced by the spring force, is determined by the stiffness of the spring. That's Hooke's law's constant, K, or the spring constant of that spring. And we can determine that if we conduct an experiment, hang a variety of known masses from our spring, see how long or how far they stretch. The amount of stretch is this delta L. If we plot that as a function of mass, the slope has everything to do with the spring constant. So that's our approach for finding something out about this spring. And once we know the K value, we can use that to determine its period of oscillation if we hang a known mass from that spring and set it into motion, capture the motion through a motion detector into graphical analysis. We'll see a lovely sine or cosine function. You just need to be careful that you're not too close to the motion detector. As you discovered in week 1, these guys have a minimum distance. So stay within the range of that motion detector, track the oscillation, and fit a sine or a cosine function to that curve. You can determine the period from the fit parameters. Or just simply count from peak to peak how long one period lasts. That's our game today in Phys 1 lab. I look forward to working with you.